All right, so this is a Jupyter Notebook example. So you're welcome to click the link, and you can just click here to open the link on Google Colab. So just right click, open in Google Colab. You do need to have a Google Sensing account, but it's free for research and education. So if you want to try it out, just click the link here on the notebook. It will take you to the Google Sensing website. So this is basically a cloud computing platform developed by Google started in 2010. So it's all over 15 years now, and it's a very powerful platform. It's free for resource education, but they also have commercial offerings. And what you need is just basically a Gmail account, Google account, then you can start using it. So here, what you want to do is to upper right corner here, if you don't have an account, just click Get Started, and then you just need to log into your Google account. The first step when you get started, if you don't have one, you need to sign up a Google project. And you can just register for Google project, click the buttons, and then just follow through the instructions. You'll be able to get an account. And then once you have the account set up, you should be able to come back to here, click the platform, and then code editor. So this is basically where you write JavaScript code to code the data, visualize the data, and also run analytics. And so the main platform is using JavaScript, but in this section, we're going to just show you some example how to use Python. So how many of you have used Python? Okay, a lot more. That's great. So it's so much easier to just use Python to do that. And so here I'm going to show you. By the way, so even to learn more, there are a lot of tutorials on the website, and also tons of geospatial data. So right now, the database I think has over 100 petabytes, something like that. So it's a huge database, and it's the volume is not something we individual resources developer can handle, but it's all out there. So if there's one take-home message going to get out of here is, I'm going to give you an analogy, right? So nowadays, all what's movies, Netflix, YouTube, and all the streaming services. We used to watch that like using a DVD, Blu-ray on a local computer, but nowadays, not many. We are not doing it anymore, right? It's so right now intuitive just to use streaming. And the same thing in the cloud computing domain is like we are also right now using cloud computing to basically stream the data, visualize the data, analyze the data, rather than having to download the data to a local computer, because you need a lot of data storage. That's one thing. Even if you have a data storage like terabyte data, you don't have the computing power. You cannot just handle data at a global scale because the data is so huge. But with this, you can stream any data at a global scale. You can process petabyte data just with a couple clicks, and just a couple seconds, you will get the result. And everything is basically very dynamic and easy. And I'm going to show you how to do that, and you will see the power of using the platform. Again, it's free. I'm not sponsored by Google. I love it. It just helped me so much. And so I want to show you how to get started. So once you're here, you will first, so if you have not used Google Colab before, you can see the table content in the upper left corner. And then, so this is just a brief document showing you how to get started with Google Sensing, how to get the data, and how to visualize that, and how to run some simple analytics. So you just scroll down. You can check out the link for more resources if you want to. And so the first step is to install the package. So you can just click this one and then run anyway. You need to have a Google Sensing account. Once you have that, you can just log in. So first step, just to install the packages, and then we can show you the step-by-step. It's much better when you see the imagery, zoom in and zoom out, creating the map, and then just take a look at that, rather than just reading the circle is quite boring. But I want, especially new to geospatial, this is going to basically open up a lot of more opportunities for you, how to actually get the data from the satellite, and then how to process the data, and then to gain some insights. So once you install the package, then you can just install, import the library. So EE basically is the Google Sensing Python library. Geemap basically built on top of the Python libraries. So you can think about the cloud computing platforms has two major components: the computing API and also the visualization API. So the computing means they say, okay, I want to figure out what's the urban growth or vegetation, how much has changed the last 10 years. right? So you can run a lot of analytics to actually get the result. And once you have the result, you might want to visualize. For example, I want to see the buildings, I want to see the vegetation, I want to see the river, anything you like. Then we want to show it on the map. So the computation API, basically Google Engine provide both the computation and also visualization for the JavaScript API. But for the Python API, it just focus on the visual computation. There's not really visualization functionalities for the Python API. So I kind of build the package to build the gap is allow you to run computation based on the Google Engine Python API, but also allows you to do the visualization. One analogy would be like you have a lot of movies. Geemap help you to spin up the server and allow people to watch the movie streaming, and then you can run a lot of analytics on top of it. So once you import the library, next you just authenticate. Then you can log into your Google Engine account. Basically, just your Google account. Once you log in, and then continue, and that's it. So the next step is to authentication means you log into your account. Initialize means you initialize a section because Google Engine is free for resource education, but they also don't want people to abuse it. Okay, kind of like I produce a movie and it's offered for everyone for free, but you cannot just come into the theater saying that okay, that's for me. You guys, no other people can watch the movie. So it's kind of share resources. So the initialization means it's telling Google you are connecting to the server. I'm trying to use it for computation. So you do need to initialize. And you need a Google Cloud project. So when you register for the account, you set up the Google Cloud project. And where you can find this project is once you log into Google Engine, upper right corner here, you should be able to find your Google Cloud project. So the Cloud project allows you to use all kind of Google services, and Google Engine is free, so you don't need to pay anything. It's all free. So all we need pretty much is just this project account. So if you click project info, and this will be basically your Google Cloud project. So if you copy that and then passing in here, and that's it. So, oops, there's a typo here. And that's it. So now we are initialized. Then you can just click here, and then you can render the map. So that's it. So you're connecting the Google Engine server, and then we can create an internet map. Then you can display it. Right now, this is pretty simple. This is just OpenStreetMap, kind of similar to Google Map, but it's open access, free. And you can allow, we can render all kind of maps on top of this open access map. So, and upper right corner here, you see the control allows you to change the, for example, layer opacity interactively. Right now, it's not seeing Google Engine yet. This is just a simple web map. But we're going to render geospatial data on top of the map. Just like you are seeing, visualizing Google Map or Google Earth, you see some satellite data on top of that, but we can bring in a lot of data and we can all render them on the same UI. So this is how you get started, get an account, authenticate, initialize, and then create a map. So next I'm going to show you how we can actually bring in geospatial data, how do we source the data. And so basically what I'm going to teach you is how to source movie on Netflix and how to stream the data and how to run some analytics, for example. How long does that character appear in that movie? Where does it appear? And what does it do? Something like that. But it's in the geospatial domain. How do we get the data? How do we filter the data to find the data what we want? And earlier some question about, like, for example, data quality, cloud, like how do we filter the data by cloud? How do we create cloud-free images? How do we create some animations out of those data? So you can continue to use Google Colab, just runs through all the code blocks. Everything is basically reproducible, but I'm going to switch to my local Jupyter Lab environment because it's a lot more smooth and it's much faster. So I'm just going to enter my here, and then so if you, it's just a Python package, so you're welcome to create a Python environment and install the packages if you want to. I also have a lot of tutorial on YouTube showing how to do that. So for here, I'm just going to open this one on Google Colab, and then let me enlarge a little bit. So the first step pretty much is the same thing. So let me clear the outputs, and then input the libraries, initialize. So I'm going to here create a map, and then you can just display the map, and you can customize it. So for example, if you want the map to center at a certain location, latitude and longitude, and then zoom level 4. Zoom level basically means this is zoom level 4, this is 3, 2, 1. So 1 means pretty much at a global scale. So the zoom level, the higher the zoom level, the more detail you're going to see. So you can zoom all the way in. So from 0 all the way to 24. So this is how all the web mapping libraries functions. And you can also change it to a different location. For example, I want to zoom the map center around Tennessee. You can do that as well. So you can easily customize both. Then you can add some base maps. So for example, if you want some other base map, so this is satellite base map. So you can bring in the satellite base map just with one line code, or you can do it even like this. Let me show you. So it's super easy to use. Just import Geemap and then just create a map. So for example, here I can just create a map, and you can just change the base map interactively. So if you click the button upper right corner here and then click this map button, and this allows you to change all kind of base maps. So I can switch to any base map like. You don't even need to know how to do coding. It's like you can change base map easily. So there are hundreds of base maps available. So basically in Geospatial, we have a lot of maps for different purposes, and you can just bring in the base map easily for mapping, using as the background, something like that. Again, this is just a simple web mapping, nothing to do with cloud computing yet. It's just like a normal web map. So next, want to start getting into Google's engine. So let me just show you the data first. And so right now, if you look at this map, we have the so-called digital elevation model, basically the elevation around the globe. And also we have the US, for example, the boundary here. And look at this DM, this data set. So this is geospatial data. Every pixel represents a value, basically the elevation of that pixel. And look at this one, looks pretty simple, but imagine you're trying to download this data. So this data can be over 10 gigabytes. And I just take 1 second just to load the data onto the map and see why it's so fast. It's kind of like you're watching a high definition movie, right, on Netflix. And when you click, you just play, but you don't actually download the entire file all at once, right? So it can be 20 gigabytes, but if you click, it plays very nicely. And you might, if your internet is slow, it might take some time, but this is essentially the same idea. So when we load the data in here, this huge DM, even if it's 10 gigabytes, but it's so fast because when you load the map, we don't need to see all the details. We don't need the native resolution. For example, earlier we have the introduction about satellite resolution, right? So this resolution can be 30 meters, but what you're seeing right now is probably 30 kilometers because you zoom out, you don't need to see the details, right? So basically the size is pretty small. So that's why it's very fast. But when I zoom in, it's going to load up. You can see the changes, the details, see more and more details. And you also see some of the bounding boxes here. It's not supposed to be, but this is basically, you're supposed to have a seamless. But this is essentially how all the web mapping functions is. You are requesting the data on demand, on the fly. So when you zoom in, you see more details, but you don't see the outside, right? Because the data is high resolution, but you're looking at a small area. But when you zoom out, you see the larger area, you don't see like so much detail. And the file size transporting from the server to the computer is pretty fast. And so you're only getting a tiny little bit. But if you're doing this one on your local computer, you need to download the entire file and you need to load it one into the memory. And that's very computational intensive. But this one is not. So that's why I said Google's engine cloud computing is very powerful. That allows you to basically render a large amount of data very, very quickly. So this is very super powerful, and you can zoom, you can change the opacity. You can also, for example, change the vector data. So we have raster data, have vector data. So this one is basically vector data. So if you zoom in and zoom out, you see this is the DM, but everything is customizable. So I can click the button here, and then you can even change the visualization. So for example, I don't like this color. For Python users, probably already know maybe matplotlib color map, something like that. You can easily change it to any color you like, and then just click apply. You'll be able to render it all at once. So you don't even need to write all many lines code. For example, here all the color looks. You can change it. You can customize it. and you can even change it to even larger one. So whatever you like, you can easily customize data to your liking. So pull in the data, change the visualization, and then render the data. And later we get into the introduction about the data type, but for now I just want to show you like at least or how do we bring the data and how do we visualize that. Pretty much the same, the workflow looks like this. So we create a map and then we are pointing to this data. So e.image means every data set in the Google Search Engine data catalog is a unique ID, kind of like in the US, your social security number. So basically we are pointing to the data set, and e.image basically is a server-side object. So that means we don't actually have the data on our memory. It's basically, okay, I'm pointing to this data set, I need this data set, and I know your name, I know your unique ID. And once I have that, I can just like specify, okay, this is how I want you to come in. Okay, I want you, the minimum value is 0, and then maximum elevation value is 4,000. And this is how I want you to look like. And after you set those parameters, and then pretty much this one, add the layer. So then add the layer to the map. Okay, I want this data set. I want what you want to look like on the map. And that's it. So find the data, tell what you want to do with the data, and then load the data. So basically just 3 lines of code. Okay, create a map, find the data, customize it, add the data, display the map, and that's it. So all the example I want to show you is following the same structure. It's very easy to use. And the second one here is the vector data. So this is basically the US state boundaries. So again, if you ever need any geospatial data, go to Google Search Engine, do a search. If you find it, you can stream it, you can download it if you want to, and it's very, very fast. So here I can even change it easily, right? For the color palette, these are all hex color code, RGB. But I can just change it to any matplotlib color map. So for example, I can use terrain and then just run it. Now I have the terrain color map. So it can be any color map that you like, and you can turn the layer on and off. You can change the opacity. So this is basically essentially how Google Search Engine functions. So the data is in the Google Search Engine data catalog, and the user get to decide what I want to do with the data. I want to visualize it. I want to do something, and just get the data and then just load it. That's it. So kind of like you go to YouTube, okay, search a topic, you find a video, you click, you play, and that's it. Same thing in here. You find the data and then just load the data. But it's not just for visualization, okay? So the power of Google Search Engine is for analytics. Just similar, right? This you can see something, for example, on Google Earth. But if you need to answer some questions, you might need to get some data, real data, original data, kind of like the pixel value. Then you can use this kind of inspector, allows you to, for example, click, and you can inspect all the pixel values at your mouse click location. So for example, this is Landsat data, what each multispectral band, each value, and also different data layer here, right? I have multi data layer here, so you can change it interactively, and you can just create the pixel value. For example, let's say I'm coming here, I click the map, my mouse on this on Tennessee, right? So it's going to basically tell you, okay, this at this mouse click location, the elevation is 202 meters, and these are all the pixel values, and also you can see polygon that I clicked it, right? So it's indeed Tennessee. So basically allows you to query the data that you are putting. So it's not just for like, okay, this looks nice, but sometimes you might want some raw data that you are seeing, and so basically Geemap allows you to actually do that easily, and you can basically plot single band data. For example, this is just a DEM, and you can change the opacity, you can change the color map easily. For example, just click here, allows you to change the visualization. Again, there are a lot more things you can customize. I'm just showing you the quick example here. You can also visualize multi-spectral bands. So this is where remote sensing really shines. It's not just RGB. So you have multi-spectral, for example, 7 to 10 spectral bands. You can have hyperspectral, basically has over 200 bands. So think about regular computer vision photo, just RGB. And this can be 10 times, 100 times more, because remote sensing sensors can sensor more information beyond the visible spectrum. You can go to high spectral, microwave. So this is what, for example, remote sensing near infrared images look like. Why is all red color? It doesn't, when you're on the airplane, you see down below, you never see red color because vegetation has high reflectance in the near infrared band. So that's why if you have RGB, if the red channel is very high, it's going to look like red, right? But you can easily change the combination, for example, to B3, B2, and 1. That means you're really using the RGB. Then if you change it, this is what it looks like true color. That means what it looks like when you see from the sky. But you're welcome to customize to any, for example, I can change to 5, 4, 3, and then applied it. This is also kind of looks like true color, but it's more like a little bit highlighted. It's still called false color composite because it's not real RGB. And you can change, for example, the value range. If you think it's too dark, then you probably want to lower the value or something like that. So allows you to basically play with it to your liking. And also the vector data. So you can visualize any vector data. So vector data means kind of like Google Map. So you can zoom in and zoom out, but you don't see the pixel. It's like vector type. So allows you to customize. For example, here, right now, I'm seeing this map and I don't like the, maybe the view color. I just want to change to maybe just the outline to be red color. And you can just one click, you'll be able to change it. So basically the data is the same still on Google Sensing server, but when it's pulling the data to our computer, we can tell what you want it to look like. You can change the outline, you can change the color, you can do all kind of things you want. And again, this is just showing you basically the visualization part. But next, let me quickly show you, for example, is where you can really run some analytics. You can extract the data out. And so, for example, this shows you the DM, the digital elevation model. And assume that you're someone walking on mountains. I just want data for this area. I don't want the whole globe. I don't care about other locations. I just want something for this particular location. I can do it easily. Okay, this is where do I want draw a rectangle, and then just run the command one line, and I get the data for this. See how powerful it is. You can basically get whatever data you are interested in. If you focus on area, you can just extract the data and see how fast it is. It's not actually saving the data. It's actually requesting a small section from the server. Just like, okay, I want, I'm interested in a particular movie, or for example, what some of the popular TV shows, for example, Game of Thrones. Okay, I don't want to see anything else. Just show me this one. It will show you. All we need is just to filter the data, get the data easily. I don't have time to go into all the details, but you're welcome to play with the notebook once you get your Google Sensing account. Okay, so I want to do a quick pause. If you have any questions, I can answer right now. No? Okay, then I will continue. So basically, it's free. You can try it out. It doesn't break anything. So it's just a Python package calling functions from the server, passing the data, and then run some analytics. So next, let me quickly show you like where to actually find the data. So again, if you're already Python users, I guess you understand these 2 lines of code, right? Create a map and then just display the map. That's it. But you can actually source the data within the platform, within the UI here. So if I click the link and then data, so from here you can just search any data. Kind of like you go to the YouTube search box, you type and then you see the video. This is where you stream the geospatial data. So you don't have to worry about, okay, do I need to download the data? Do I have the computing power? You don't have to. So I can source any data. For example, I say I want the elevation. Just hit enter and take a look. So you have a list of all available data sets that meet your source criteria. And then, so all you need to do is just maybe simply select the data that you are interested in. For example, I want maybe find some data, for example, RSDM, DSM, global DM, and you see a small thumbnail here, and then only just click import. So this is basically where the code block you can use to basically load the data set to the map. So I can just copy, and you can create a new map if you want to. Right now, this one is using like uppercase map, but I'm going to just change it here and take a look. It might take some time to load up, but again, this data set is like many gigabytes. Not sure exactly how much, but you can see here. So we can load the data easily. So we can search it, find a code snippet, and then just load the data. You can basically any data set. So right now, the catalog has over 100 petabytes. and you can get any data that you want. It doesn't matter how big it is. Even if the data set is like 100 terabyte, it will load it just like this. A couple seconds, you put the data onto the map, and then you can just use the tool to change it interactively. If you see the spinning, that means it's still loading the tile. So when I zoom in, it's going to request the tile. So it might take a couple seconds, depends on internet speed. But essentially, you're just visualizing Google Map, Google or something like that. But you have more control. You can find out the data that you want, and then just pull in the data, and then you can overlay on the map. You can change the base map. You can do anything you like. So this is basically the kind of fundamentals, how Google Engine works. They have the data catalog, they have the computing power, and then also have the visualization. So the data catalog and the computing is handled by the Google Engine server, and you can generate basically the tile URL, and then the tile URL is being rendered by the map using Geemap. So you have these three components together. Basically, is what Google Engine is about, what cloud computing is about, is data, computing, visualization. So we have three components. And so next, let me quickly go through the data types, like what kind of data Google Engine has. So the first one is image. So image basically means you have a single image. So for example, let's say you might have your camera, you have taken a photo, for example, right now in this room. So there's one image. But I can also take a series of images and then put them in a folder. Then it becomes an image collection. So image collection is just basically a bunch of images, like share some similar characteristics, maybe the same location, the same person, or something like that. And so for the image is one single one. Again, each image has a unique ID in the server. So you can look at all the basic information just by typing the object. And then I can visualize the images just like this. So you see this example earlier. Basically just, okay, this is the image I want. This is how I want to visualize that. And then just load it on the map. For image collection, you're just pointing to the entire image collection. So this is the superpower of Google Engine. So this image collection, this is called Sentinel-2 harmonized dataset. So this collection has tens of millions of images. And this dataset itself is hundreds of terabytes. I can guarantee you, because it combines two satellite sensors. It's hundreds terabytes of data. And all you need is just like this. Okay, I want all the images. So for example, you can think about, okay, I want something pointing to all the images that you have taken using your phone. And that's it. So pointing to that. And then you can just tell the Google Engine, okay, I want you to find out all the images intersecting this particular location. For example, I want all the images for Nashville, Tennessee. And that's it. Just filter by the geometry, basically by the location. And then it's going to tell you how many images there. So basically right now it's looping through the entire catalog, like millions of images. And it's going to tell you, okay, you have 516 images covering this location, a particular location. And then you can look at the first one, okay, just bring out the first one, see what kind of information. So basically the metadata the image has, and then I can just load the imagery to the map. So look at this. Right now, this one has a lot of, for example, cloud cover. We can also sort by the cloud cover to get the base imagery if you want to. So satellite, you're gonna see a lot of images with cloud cover because this is just the normal weather that we encounter every day. So optical data cannot penetrate the cloud, so you're going to end up with a lot of cloud. But we can actually filter the data easily to create some cloud-free imagery. Kind of like right now, all the smartphones, right? You can have your phone taking a camera, taking a bunch of photos, and then you do some AI and then give it the base one. Even like some of the quality might not look good. Same idea here, we can do that in Google Engine. So for example, for this location, for example, Nashville, Tennessee, it has 516 images. And some data might be good, some might be bad, but I can just one line of code, taking the median of all the pixels for every location. So think about here, I have 516 images for this area. So for every location, you have 516 pixels, values for every location, like a time series. And then, so you take the median value, that means, okay, it's not too bright, it's not too dark, and just get the base value. Maybe it's January, like for this location. The other one, the base value might be February. So the date actually is different. And then you put them all the base quality pixel together, and this is what you end up with. So right now, basically, we are processing 516 images, and we basically create a median filter to show them it's still loading. Not sure why it's not coming out. It's supposed to come up. So if you see this still loading, that means it's still running the computation. Once the computation is done, you should see the images. Look at this. So we are processing 516 images altogether to use some kind of image. This one doesn't really have a lot of cloud. And you can see it's popping up box by box. So 516 images. So think about here, each image is more than 1 gigabyte. So basically we are processing over 500 gigabyte of data, and see how fast it is. It's popping up. It takes a couple of seconds, but think about if you're trying to process 500 gigabyte in the cloud, it's going to take you some time. And again, you need to make sure that you set up the cloud building properly. Don't accidentally spend hundreds of bucks or thousands just to process. But this is all free. I don't have to pay anything. And you can see now I have this imagery processing the entire catalog and 100 gigabyte just by a couple of seconds. And again, you can do a lot more things. This just do some. All I need is just one line of code. So see here, median. I take a median. You can take percentile. You can take the mean. You can take the standard deviation. So there are a lot of options that allow you to customize this. And you can also do visualize feature collection. So feature collection basically is just vector data. So vector data means you have the geometry, and the geometry has associated attributes. So so in geospatial, basically you have raster data, kind of like static imagery. You have all the pixels. Vector data basically is just geometry with associated attributes, and then you can do the filtering. I don't have time to get into all the details. If you're new to geospatial, this is something that you need to learn the basics about geospatial data format. Once you get used to it, you can convert data. For example, I can convert from vector data to raster data. I can convert raster data to vector data. But Google Search Engine can handle all that. So allows you to visualize vector data or raster data. And so this one shows you, for example, the example I show you, this is showing you the boundary of the state of Tennessee. And you can also visualize, for example, a state boundary. It's a little bit slow today. It's not supposed to be. This usually is just within seconds. So once you run the source code, you're able to get the result easily. If sometimes you get stuck, you can just restart the kernel, and then you can start from scratch easily. So for example, here right now, I don't want to wait for too long, and I can just restart the kernel. But once you restart, you always need to go back to, for example, import the libraries, authenticate, and then just initialize. And once you have this, then you can go to the code block. Yeah, probably it's just the Google Search Engine server busy right now. This one usually doesn't take too long. So basically, if you are connecting to the Google Search Engine server, you need to initialize the section. So sometimes if you are doing too much computation, sometimes they might throttle your connection. So it might not work immediately. So, but you're welcome to try that out. And interesting. So basically, probably I'm requesting too much data. So right now I'm kind of waiting to initialize. But again, there are a lot more. Let me let's wait until. So the downside of this is if you cannot connect to the server, there's nothing you can do. So if you're trying to watch a movie on Netflix, if the server is down, you're out of luck. Okay, and so this is basically sometimes you have to take into account. But okay, it works now. So I authenticate. So now I can go back quickly to the section here, showing you the this section. So for example, let me just show you this one. Look at this. So this is basically all the road street network in the US, and you see how big it is. Data set is just massive. So these are basically all the entire data set. It looks basically behind it's seeing is vector data, it's hundreds of gigabyte. And but if you zoom in, it's basically just the raw network. And look at this. So this is all free open access. So the data basically from US census. So you get the data. So again, sometimes if the internet is slow, you might take some time to load up the tiles. But under the hood is Google Engine converting all the vector to raster tiles and then render the map. So you can see all these street networks. So in the computer vision world, sometimes you might, if you're dealing with satellite imagery, for example, you want to detect the roads or something like that, you need some kind of this data as the ground truth, right? So if you, let's say you detect cats and dogs, right, you need to those labels. So in geospatial, those labels sometimes come from data sources like this: roads, buildings, trees, something like that. So with this kind of data, you can actually export the data out easily from Google Engine. But keep in mind that this is different from Google Map, okay? Google Map is free, but you don't get the data, okay? You don't get the underlying data. You're just seeing the render version, but you don't have to access to the original data. Just like Netflix, right? You can watch any movie you like on Netflix. But have you ever tried to download the original MKV or whatever from Netflix? They probably don't allow you to do that. But of course, you can try some unprofessional ways to steal, like for example, like YouTube, you can still download the video like bypassing some of those. But this is all the data from the public domain, so it's free open access. So any data in the Google Engine server, it's free, so you can actually get the data out if you want to. And so I'm going to skip all this here. You're welcome to customize it, do all the data. You can do all kind of visualization, whatever you need. And you can change the color, you can change the visualization, you can do whatever you like. So the visualization, you have full control. Just like you can decide what clothes you want to wear every day. As long as you have the clothes, you can do whatever you like. You can paint different color to your liking. Any questions? Yes. Yes, so you can upload data to the server. So you can think about the entire data catalog is in the cloud. So if you want to use the cloud computing power, the data need to be in the cloud as well. So if you log into, for example, to your Google Engine account, and so here, code editor, it allows you to upload data to your own Google Cloud bucket. And then you can put the data into the Google Engine. You need to basically ingest it. So what you can do here is assets. And this is where you can create a new project, and then you can just upload whatever data you want. So you have data from the drone or UAV, whatever, you can upload, for example, GeoTIFF. So this is the common geospatial format. And you can upload unlimited data as long as you, they used to provide, I think, 50 gigabyte for free, but I think they have changed to like using the Google Cloud bucket. So you can just upload data, and for the computation is free. So basically what you need to pay maybe just the storage, and it's very cheap. So you can, once it's ingested, but it's different from just the Google Cloud bucket. You need to ingest the data into the Google Engine cloud computing infrastructure. So once you upload the data, and then you can pull the data into Google Engine, and the data sit in your own individual account. And so all the data set is going to generate a unique ID. And then you can just use the same thing. So for example, once you upload the imagery, it's going to give basically your data set, basically you're going to have a unique ID like this. Then you can just, depending on the image or image collection or face collection, it's the same workflow. Only thing is like ID is different. So you can get data set. Once you upload the data set, you can get the data set. For example, I don't have any sample data set. Actually, I maybe have some here. For example, this is the data set you upload. And then you will be able to get this unique ID from your project. And then you just copy this one and then paste into the source code here, and that's it. Then you can load the data easily. So for example here, let me copy this one, right? And let me see what's the data set. So this is basically the vector data. And so once I have that, I can come back to here, just replace it, and then run the code block. Although this is a different location, so this one is in Florida, but you should be able to see the data coming out from here. So the same workflow, the only thing is the unique ID is different. Maybe the data is not available, but this is the kind of workflow how you do that. Any other questions? Okay, so next, I'm going to talk about quickly how do you get the data out. So I'm going to show you how to download movie from Netflix. Like you like the data, you like the movie, but now how do you get the data out? So like I said, all the data in Google Search Engine Catalog is free, so you can download the data, but you do have to keep in mind that it's not unlimited, so it's a free resource. But you're trying to get like terabyte data, you basically need to wait in line. Just like, okay, I produce this free movie, everyone is welcome to come to the theater to watch, but you cannot just take the whole theater and then block other people from getting access to the theater to watch the movie. So you do need to basically wait in line. If you're downloading large amount of data, Google Search Engine is not the ideal platform for that. So the power of Google Search Engine is for computation, not for doing data downloading. Although it has a lot of functionality allow you to filter the data, but if you're trying to download terabytes data, you better go to the original source to download the data. So for example, you're trying to download a lot of videos from YouTube, from a particular YouTuber, it's probably not a good way to just bypass Google YouTube's limitation to download. You better just reach out to YouTuber saying, "Oh, like your movie, can we work together?" And you get the data out. It's actually much faster. But I'm just going to show you if you do want to get some data out, you can do that easily. So for example, here this is just a simple data set, like for example, lane set, and I want to export some data. So here, for example, this is just one lane set thing. So earlier, we already covered the basic introduction to satellite data. So this is what it looks like. It's basically just like a rectangle, but it's along the satellite orbit. So it's kind of a little bit shifted. It's not like two rectangles. So you'll be shifted along to the orbit. And suppose it's, I think just the internet is a little bit slow, but you see the full picture. So for example, this imagery for lane set, what this one is lane set 8, right? So usually for each image is 1 gigabyte. For this kind of lane set data, it's over 1 gigabyte. So if you're trying to download 1 gigabyte, it's fine. But if you're trying to download 10 gigabyte, 100 gigabyte, it's going to take some time. So for example, I can just specify like a small area. For example, I just want the Bay Area. I'm interested in looking at maybe the lane cover changes in this area. So you can specify a rectangle, and then you can just export image, and that's it. So you're going to download data to your Google Drive, and you can specify the file name that you want, and the scale basically is the spatial resolution. So satellite has the spatial resolution. So the smaller the number, the more detail you're going to see. 30 meter here is the original native resolution of the Landsat data, 30 meter. But the number that you choose here is very important. So the larger the number, the coarser the resolution, the less detail you're going to see. The higher the number, the more detail you're going to see. But don't go beyond the native resolution of the imagery. So for example, if the lens is 30 meter, your base quality will be 30 meter. You cannot go below 30, right? Just like you're using a dummy phone to take a photo, and then, okay, the photo doesn't look good, I want a super resolution. Then you need to run some deep learning algorithm to do super resolution. The image itself doesn't provide higher quality than that. But you can download the data, you can export the imagery. Also, it allows you to download multiple images. For example, this USDA, for example, has this National Agricultural Imagery Program that has data for the entire US. And so, for example, for this location, I have 7 images. So if you want to get the data out easily, you can just one line code, download all the data. So kind of like you would like a TV show. I want to get all the episodes for this TV show. Just one line code, you can get all the data out easily to your. So it's going to download data to your local computer, or you can specify to your Google Drive, or you can download to your Google Cloud storage. So it depends on where you want to put the data. But like I said, for small data set, you can download it directly to your computer. For large data set, you better just send the data to the cloud storage. So you're going to take time to download. So once it's ready, you can download the data from Google Cloud Storage to your local computer. You can also download vector data. So Google Sensing basically has image collection, and then feature collection. So those are the three major data type of Google Sensing. So image is just one single image. Image collection basically have a bunch of images. Feature collection basically means it's vector data. You have geometry, and then you have some basically a spreadsheet associated with the vector data. So you can download all of them all at once. So here basically just one line code, and then just download to my local computer again. I think the internet is a little bit slow today, so that's why you see it's kind of usually it's pretty fast. Only a couple seconds you should be able to get all the data that you want, so you can easily export the data out of Google Sensing and also vector data. And so to save some time, I'm just going to cancel this one. So the next section is more interesting. So you can actually play with this. So I'm going to show you the power of creating satellite animations. And so let me run this one again and switch to this section. It's going to be pretty quick. So I'm going to show you here. Again, I'm just going to create a simple map with a particular location. And this allows you to basically create satellite animations. So the service is changing all the time. So we have satellite in operation, collecting all the images all the time. And so we can use Google Sensing to pull all the data and then reorganize the data to the way that we want. And then we can create the animation easily. So behind the scene, it's processing tons of data. So think about if you have ever taken any photos of a particular object or your friends, whatever, and then you just take a look at this. So this is using lensing data, and then we just create an animation of Las Vegas urban growth. So see the data images since 1984 all the way to, you can set 2025 if you want to, and see how cool it is. It only takes you 20-30 seconds. So this allows you to create animation for any location around the globe. So behind the scene, it's going to basically grab all the data covering this location. And then, so you might have data for every week. I can create base imagery for annually or weekly or monthly, whatever you like, and then create the animation. So your upper left corner here shows you the year, for example, from 1980s to now. So basically, all the satellites, so this imagery have been captured since 1980s. So we have the entire archive in the data catalog, and then all you need to do is just to specify the location of your interest, and then you can use Google Sensing to process the data and process a bunch of low quality images into high quality images. Just like what I said earlier, you can remove all the cloud, and then you can create a cloud-free imagery for every year or every quarter, every month, whatever you like. So you can specify the basically the frequency. So there are local parameters you can control here. So for example, I can set that by default the frequency is by year, but I can change to months or quarter, depends on if the data supports that. But it's basically just 2 lines of code. But if you really hate coding, if you don't know how to get started, let me show you an even easier way. Just import Geemap and then just create a map, that's it. And going from there, I don't really need to write any lines of code. I can just maybe go somewhere here, anywhere that you like. For example, I want to see maybe, let's say I'm a hydrologist. I'm studying river dynamics. I'm interested in this location, right? So, and you're only 20 years old. You want to see the data back into the half century. You can do that easily. So all you need to find this location that you want. And then, okay, let's say, or I want this area. I want to look at this location. I want to see how it has been changing the last half century. Just draw the rectangle, and then you can click the tool, and then click this button. Now it shows you the satellite-based map, and that's it. Just click one button, and then you will basically behind the scene is going to actually grab all the data from Google Sensing, do all the processing, removing all the cloud, and then going to show you the animation for the last half a century. Again, this works for anywhere. It doesn't have to be this location. It can be any location on the globe, because all the satellite data has global coverage. And again, it's going to take you some time. So this is not instant. Usually 20-30 seconds, you should have the animation. because behind the scene is processing thousands of images because the data have been collecting since 1984. So you have the entire data catalog and then just use it to do all the processing. I hope it works. Sometimes if you're requesting too much data, it will not allow you. But for small area, even it's half a century, it should still work. So this is basically no code solution. So you don't actually need to write any code to create animation. And if you don't want to use Google Sending or you don't want to apply for an account, I also have Hugging Face Lake deploy as a web app, so you can actually directly use Hugging Face. Just go to web app. You will be able to also create animation. I think somewhere here allows you actually to. I'm not sure if it still works. Sometimes I need to re-authenticate. So the same thing here. Just go to the URL and then you can draw a rectangle. You will be able to actually also create animation easily. So here also shows you some of the basically how to do it. Go to the link and find the area of your interest, and then you can draw basically a reason of interest, or you can upload one from your local computer, and then just adjust some parameters. Then you'll be able to get the animation. Okay, so it finally is here, but see how cool it is. Like I find any location that I'm interested in, I just draw a bounding box, and then you will be able to create animation, getting all the satellite data for the last 50 years. And then just create a cloud free, see how good it is. Think about you taking all the photo, for example, your kid from the very beginning to when after they reach 50 years old. So you have all the images. You don't have to worry about where are they being located. You just say, okay, I have all the images in this folder, create a nice animation, and then just make them consistent. And so here I can see this template. Let me remove the area here, and you can even change the opacity. So this is what it looks like right now over there. And this is what it looks like. It's changing, right? See how dynamic is the river channel? So this is something super powerful, especially by teaching kids like how the river changes, this type of dynamics, and how those oxbow lake forms or something like that. You cannot just read this from a book, right? It's static, but geospatial is very dynamic. So you have the map, you can see changes. Like I said, it can be anything happening on the Earth surface. If they can be captured by the satellite data, we can use it to create animation easily. And it doesn't matter how big the data set they are handling. It can be petabyte of data. We can still process it pretty quickly. Just 20, 30 seconds or a minute or two. Think about without cloud computing. This simple animation can take you many hours to create. So think about this might be processing 100 images. So you have to go to the USGS or NASA to download the data. And then you need to have the storage. Once you have the data, some of the images are really bad, have cloud, some don't have cloud. And you need to create like mosaicing them together, especially working on a large area. You need to download the data, mosaic, stitching them together, and then create cloud-free, nice looking, and then put them all together as animation. This, like you can spend a day or two. You don't even get the good result. But as you can see here, all you need, 2 lines of code, and then just use the GUI, or you can just use the web app. You don't even need to write any lines of code. So this is how you can do it, but you're welcome to try out other examples. So for example, I can show you some other location. For example, if you know the exact location that you're interested in, you can specify the bounding box, basically the longitude, the latitude, the lower left corner, the upper right corner. Basically, all you need is just those 4 coordinates. And once you decide, then you can just use it to pass into the program. So only basically just one line of code. I want to create a Landsat time lapse, or I want to create a Sentinel time lapse, or MODIS, or basically any time series, and just one function, and then you can apply it to create animation. So this usually takes 20-30 seconds, but take a look. So this is the evolution of Hong Kong. This is the Hong Kong airport, constructing, I think, around 2000. Have anyone been to Hong Kong before? Also, the upper right corner here, look at this. Where is this? This is the Disneyland over there. But like I said, everything is being captured by the satellite. So as long as you know how to get the historical imagery, you can create any animation that you like. So if someone really interested in studying the environment, right, there's nothing better than looking at these images. It's live. It's not just looking at a page, a static page on a book. You can really see the changes. Then you can try to study, is this why this is happening? Where is it going? What's the driving factors? And how do we better, for example, protect the environment? And it's super powerful with this kind of satellite data to actually showcase how things are actually changing. And you can also use, for example, Sentinel-2 models. For example, let me show you this one. So if you're someone studying, for example, ecology, biology, you always wondering like how the vegetation changes throughout the year. And we can do looking things at the continental scale or at the global scale. You're not looking at individual plant. Of course, you can if you have the data, but most of the set data is like high up in the space. So it's like the resolution is not super high. But if you're someone looking at like global pattern, continental, this is super powerful. So all we need, okay, create a map, draw a bounding box, and then okay, saying okay, I want this satellite, and that's it. So with that, you can create the animation. Like I said, see how cool it is. So this is showing you the vegetation, the phrenology changes in Africa. Look at how nice it is. Like this is long-term average. And so the Earth actually is not static. It's very dynamic, just like human being, right? You can see how it's just like human heart beating, breathing throughout the years. And this is the overall, for example, 20, 30 years data. So you can see how the vegetation shifted north and south depending on the season, right? So if you look at on the upper left corner here, showing the, for example, the date, the month and the date, so you can see how it's shifting. And this is not something you can do, you can see on the ground because there's only one specific point. But looking at the high space for satellite data, this is really interesting. So certainly the lot of questions like, oh, why is shifting this and shifting that direction, not in the other direction? How much is shifting, and how much is being contributed by the natural environment? How much is being impacted by human factors? Anyway, just Go Sense is very good for it to showcase what it looks like, and it's up to us to decide what do we want to study, why and how is it going, something like that. So it can be vegetation, it can be temperature. For example, if you're someone interested in looking at surface temperature changes or ocean temperature, you can do that as well. So we have set the data has a variety of resolution ranging from very high resolution using UAV to something like several kilometers looking at like overview, big picture. And there are a lot of data that allows us to do that. So if you ever study any, for example, books on physical in geography, for example, how the ocean water shifting throughout the year, and you can create something like this easily, as you can show in here, just a couple lines code. But again, if you don't want coding, you can use the web app. You can also do that easy. So the last example I'm going to show you is the GHOST time lapse. So GHOST basically stands for geostationary observation environmental satellite managed by NOAA. So basically, this is very powerful for monitoring the weather patterns. So for example, wildfire, volcanic eruptions, hurricanes, something like that. I can guarantee you probably have seen something like this on TV or on social media, right? If you have any. So this one is the Tonga volcanic eruptions, right? Being captured by the satellite. So the satellite gives imagery every 5 minutes. So you basically take the snapshot. And this is very coarse resolution because the satellite is very not designed to capture fine details, but for weather and climate, right, you need data that at the large scale, broad area, and see how cool it is every 5 minutes. So so all the data is actually free, so you can actually just focus on, okay, what question I want to address, what research do I want to do. You don't have to worry about like, okay, where the data, how do I download the data, or do I have enough storage? And even if you have the storage, like, do I have enough compute? And all we need is basically a couple lines of code, and it's running. It can run on anywhere. So I can even use my iPad to do this. It's not a problem. So you can do it, for example, volcanic eruptions. You can create, for example, hurricanes, wildfire. There are basically any data in the Google Sensing data catalog. As long as they have the time series component, we can request the data easily using this way. So all we need to figure out, what do I want? What's the location I'm working on? What's the time period you're working on? And how much data do you want? And you can just, again, you need to wait maybe 10, 20 seconds, but it's probably much faster than you trying to download the data, trying to process the data yourself. It's going to take a whole lot more time. So for example, this can be hurricanes, right? So this is all being used by weather forecasting. And you might have seen some things like this on social media. But now you know how to create yourself. All you need is just import the library, figure out the data you want, and then just tell Google Sensing, okay, I want the animation. Just give me the animation. But beyond just creating time lapse, just like, okay, this looks nice. So what? Like, what's the impact area? How much has been changed? Or how is the Wi-Fi going? You can also run analytics, and you can also get the data lake, the result you can overlay on top of that. So definitely there are a lot more things you can do just by visualizing data. So visualizing data is the first and the last step to me. But there are a lot of things can happen before the data input and the data output, because you can be your own algorithm. So for this example, showing you, for example, keep track of the Wi-Fi spreading, right? So you have the imagery capturing the data every 5 minutes. So you can see the smoke, you can see how the Wi-Fi is spreading, but you can also see the pink pixels. So this one actually is detecting the Wi-Fi area. So you can have the original data, you can also have the analytics result overlay on top of the original data. So you can quickly create something like this. And so this one is in California. So you can clearly see how powerful these kind of tools can be, because you can access to the data in near real time. So once the data being captured by the satellite, it's being ingested into the Google Sensing server pretty much in near real time. So maybe 10, 20 minutes delay, and that's it. So once you have that, you can get the data, you can run an analysis, and you can do things like that. So so this is kind of a brief introduction into Google Sensing. And the last part here is that beyond 2D visualization, you can also visualize data in 3D. Although it's not a focus, but you can certainly create data in a 3D globe like this. So for example, this is global land cover data. And this one actually is from Geemap. So I will cover more examples this afternoon, more like how to use Geemap. So Google Sensing is great, it's powerful, it's free for research and education. But I know a lot of people don't want to use Google products. It's fine. You can use Geemap. Geemap allows you to use in any cloud computing platform. It doesn't have to be Google. But if you want to create map, you want to visualize data, Geemap can help you there. So I cover this afternoon, but I just want to show you, like, beyond 2D visualization, this is how you can use 3D globe to visualize the data. And again, the data, for example, this data set is tens of gigabytes, but I can visualize data easily here, and you can zoom into any location that you like, and you can load the data on a 3D globe. And so it's much better than just 2D, because 2D, if you're working on the maybe polar region, you might have a lot of distortions. 3D don't have the distortions. And so also here, I can, for example, render multiple data. For this one shows you the nighttime light data here. So you can pull data from Google Sensing, but we use Geemap to render the data. So for example, this is nighttime light, and everything's interactive, so you can turn layer on and off. If you really want, I can even render data in 3D. So let me show you this one last example. Oh, the 3D terrain is actually already 3D. So let me show you how it works, right? So this one right now looks like a 3D globe, but you can actually zoom into any location that you like. So for example, I'm going to zoom to here. So this one is maybe a volcano. It may take some time to load up, but the nice thing about this is behind this, beneath the data is actually rendered in 3D. I'm not sure why it's not coming up, but look at this. So this is the volcano, right? And again, the Google Sensing data there is a little bit slow, but if the internet is faster, you will be able to see so much better. Basically, you can render all the data in 3D. So if you just maybe turn off the Google Sensing data layer here, just by simply looking at the Earth surface, and this is all 3D. and so you can render data, whatever kind of scale the data that you want. You can all do it in 3D, kind of like in Google Earth. Then you can render data like this, but this is free, and you can use it for any commercial applications if you want to. And this looks complicated, but it actually it's not. You can just do it in 2 lines code. So 2 lines code to create a globe with satellite data, and you can overlay, basically has the terrain, so it can go anywhere that you like, and you can render the data pretty quickly. So see how powerful is this. Again, you're welcome to explore. It's free and open source, so you can do a lot of cool things on top of that beyond just the traditional photos and videos. And again, I'll cover more this afternoon. Okay, so that's all I want to share. Happy to take any questions. If you don't have any questions, you're welcome to. Yes. You mean area view? So this one is basically this just basically a base map. So this can, if you depends on zoom level, if zoom in and zoom out, so the data actually come from different data sources. So when you zoom out, zooming out, basically you don't need the detail. Those are usually coming from the satellite. When you zoom in more details, for example, if you don't need the 3D, you can change it to 2D. Then you will use maybe some other high resolution satellite. But some of the data might be commercial, like from commercial providers. Then if you use for commercial application, you might need for license. But you can use a lot of free base maps. So for example, here you can just use the projection. So from here, this is, you can use the globe, or you can use some other projections from here. So kind of very similar to what I did earlier for Geemap. It allows you to load any base map. So there's some free one, there's some also paid version, but it all depends on what your application requirements. There are a lot of already data out there that you can just pull in easily. But if you have a particular application, I can show you some of the base map example that might be good for your use case. Any other question? Yes. Yes. So if you capture from a drone, usually you'll be already, for example, GOT, for example, a geospatial format. You can also use leaf map to actually to render it easy. So you can put the data in the cloud, or you can put the data locally. Either one is fine. I will show you this afternoon, but let me see here. I don't. I have examples. For example, let me show you quickly. This is for leaf map, right? So here, this afternoon I will cover, for example, how to add local raster data set. So pretty much like I have the data in the cloud through access through HTTP URL, or I have the data on my local computer. You can either use just one line of code, add raster, that's it. Create a map, add raster, display the map. So you can render any geospatial data using leaf map. Any other questions? Okay, if not, thank you. And again, the notebook is on GitHub and also on the website, so welcome to try it out. If you have any questions, feel free to post questions on GitHub. I'm happy to help. Okay, thank you very much.